welcome back to ScottScience. Today we want to talk about tension. Tension is the force provided by a rope or cable. Here I'm climbing this tall wall here. Without this large force of tension here, I would fall right down. Let's talk about something. So here we want to talk about tension. Tension is a force provided by a rope or cable. But in order for us to understand that, we have to kind of talk about force. So here I have something called a spring scale, and it measures a force or a pull in newtons. If I have it still, it reads 0. If I pull on this, it goes up. Now, here I have a 1 kilogram mass. On Earth, it weighs 10 newtons. Our formula for weight, Fg, is mg. So on Earth, 1 kilogram, which is our mass, times 9.8, gives us about 10. So what I'm really trying to say here is this mass, this thing here weighs about 10. So if I put it on our spring scale here like this, it reads 10. Now keep that in mind. We're going to use that to think our way through some problems. If I just have this hanging here, it needs to pull up with 10 in order to hold this thing. Here I've got another spring scale like I saw before, but now I have it flipped upside down. What do you think it's going to read now? Zero's there. We flip it upside down, still shows the same thing. Okay, so let's say you get that one right. Let's keep going. Here I've got our 10 Newton weight. I now have a rope in between that and the spring scale. What do you think it's going to read? Something about 10? Now say why. Well, that rope is just connecting the two. In an ideal world, does the rope have some mass and should actually have to pull more? Yeah, but for our instances here, we're saying the mass has very little weight in terms of the rope. Now things start to get interesting. Now I've got our hook first, spring scale attached here. There's a spring scale behind here, goes over a pulley and attached here. How hard does the rope have to pull up in order to hold it? Well, pulleys make things easier, right? But how hard is it to have to pull up? Let's check it out. Notice it reads still something like 10. Well, it's still only pulling it up with 10 newtons of force. It changes the direction, but doesn't make it any easier. Let's keep going. Now in this case, a rope is attached here, goes around a pulley. Our mass is at the bottom and goes up to a spring scale. What should it read? The 10's down there. It really reads 5. Because there's 2 upward forces. This holds 5 and that holds 5. So let's keep testing. Now we've got our mass here, rope starts here, goes over a pulley here, and we're attached down here. What do you think it is now? 10, 5, 7, 11 and a half, pi. Five's right there. It's pulling up twice. Well, what about this thing? That's just changing direction, right? So each one holds 5. The tension in the rope is equal. Let's keep going. Now our mass attached here, pulley, rope goes from here around, and down. Take a look at this. Attached here, pulling up. What should it read? Something like 3 1/3. 1's there, 2's there. That's about 3 1/3. Well, why? Let's see how we got 3 pulling up. 1/3 of the total. 1/3 of 10. Let's keep going. This is the cool one. This is why we're doing all this. Ready? Here I have a mass attached here. There's a spring scale behind there. Rope goes here, goes over to there. Over on that other side, spring scale and mass there. So, mass, spring scale rope, spring scale in the middle, spring scale mass hanging down there. So, what are they going to read? Well, let's look at the ends first. Like this. Hanging 10 here. There's a rope attached. Shows 10, right? Okay, let's look at the other side. Look, 10. Okay, both sides show 10. But what about this in the middle? In the middle, will it show 0? Will it show 10? Will it show 20? What will it do? Something just about 10. Now, if you said, why doesn't it 0? Well, do the ropes still have to hold? Yes. Why isn't it 20? Well, if it was 20, that means we'd have a bigger force in the thing. And then we start accelerating, which doesn't make much sense. Now, tension in a system is the same throughout. So in that case, it's 10 at the bottom, 10 at the top. Think about it. It makes no difference if I have this thing and I put my hand here, right? It's just like me holding it. Just like before when we saw the rope holding that thing. It's pretty cool. Tension's a weird idea, but if we think about it in small steps, it's not that weird at all. So why so tense? As always, thanks for watching.